Good day, grade 11 learners! I am Teacher Andrew and welcome to Telemath Aralan. This video is made to help you master the domain and range of a rational function. Yesterday's lesson is about representing a rational function through its table of values, graph, and equation. After watching this video, you are going to find the domain and range of a rational function by applying yesterday's lesson. Let's set to find the domain and range of a rational function. Now, imagine that you are 96 kilometers away from Manila. You are planning to visit your grandmother who will be celebrating her birthday. Your father has allowed you to drive his car so that you will arrive at the party on time. Assuming there will be no traffic that day, you have resolved to arrive at the party from 1 to 2 hours. So, at what speed are you going to travel to arrive in a certain period of time? For your activity 1, construct a table of values that would represent the given problem. Subsequently, plot the values obtained on a Cartesian plane. You may use paper and pencil or apply graphing apps such as Microsoft Excel, GeoGebra, or Desmos. You may use this table as your reference. Let's have the answer. If you travel 1 hour, your rate in kilometer per hour is 96 or 96 kilometer per hour. If your time of travel is 1 and 25/100ths hour or 1 hour and 15 minutes, your rate in kilometer per hour is 76 and 8/10ths or 76 and 8/10ths kilometer per hour. If your time of travel is 1 hour and 30 minutes or 1.5 hour, your rate in kilometer per hour is 64. If your time of travel is 1 and 75/100ths hour or 1 hour and 45 minutes, your rate in kilometer per hour is 54 and 9/10ths kilometer per hour. If your time of travel is 2 hours, your rate in kilometer per hour is 48 kilometer per hour. Now, observe that there is a set of values that can be found in X. T, as used in the preceding problem, that corresponds to a unique value in f of x, or in the latter case, r sub t. In the graph, it can be seen that these x values represent the points plotted along the x-axis called abscissa. Corollary, the x values are considered the independent variable or the input, while the y values are considered the dependent variables or the output. In forms such as linear form, y equals mx plus b, this can be extended to quadratic, polynomial, and rational functions. The symbol f of x is used instead of y. So, y equals f, open parenthesis, x, close parenthesis, and can be read as y equals f of x. In our study of rational function, these x values represent the domain and the y values represent the range of a rational function. The domain of a function is the set of all values that the variable x can take, while the range of a function is the set of all values that y or f of x can take. But how do we determine and write the domain and range of a rational function? If you can recall, we can write the domain and range using different forms. Number 1, by roster format. This method enumerates the list of all values in the set. Example, the domains of R sub t are 1, 1 and 25 hundredths, 1 and 5 tenths, 1 and 75 hundredths, and 2. Second form, by set builder form or notation. For example, in numbers 10 to 20, you can say x such that x are even numbers from 10 to 20. The vertical line symbol is read as such that. Assuming that you also include odd numbers in the domain from 10 to 20. Then, you can write the domain of the function d sub x as x such that x is an element of real number, x is greater than or equal to 10 but less than or equal to 20. Third form is by interval notation. For example, in a function f of x equals 5 all over x minus 3, the domain of this function can be written in the form negative infinity and 3, union 3, and positive infinity. This means that the values of the domain can take all real values of x except 3. Otherwise, the function is undefined. Let's try this. Let's find the domain and range of the rational function f of x equals x minus 2 all over x plus 2. First step is, let's find first the domain. In finding the domain, equate the denominator to 0. X plus 2 equals 0. To find the value of x, apply subtraction property of equality. Subtract 2 on both sides of the equation. Then x, 2 minus 2 is 0, and 0 minus 2 is negative 2. Negative 2 is the value of x that will make the function undefined, because negative 2 plus 2 is 0. Therefore, our domain is all the values of x such that x is an element of real number wherein x is not equal to negative 2. Next step is, let's find the range of the rational function. Remember that f of x is also equal to y. And in finding the range of the rational function, it is just like finding the inverse of a rational function. Okay. So, let's substitute y to f of x. Y equals x minus 2 all over x plus 2. Let's rewrite the problem. X minus 2 all over x plus 2. Multiply both sides by x plus 2 to cancel out the denominator. X plus 2 and x plus 2. Let's apply distributive law. X times y is xy. And 2 times y is positive 2y. Equals, cancel out, x plus 2. Bring down x minus 2. Now, let's combine terms that has variable x. So, Let's rewrite first so that you can see the step-by-step process. X minus 2. Let's apply subtraction property of equality. So minus x and minus x equals x times y plus 2y minus x. X minus x is 0. Bring down negative 2. To eliminate 2y, let's apply subtraction property of equality. So xy plus 2y minus 2y minus x equals minus 2y minus 2. 2y minus 2y is 0. Bring down x, y minus x equals negative 2y minus 2. Factor out x. X, y minus 1 equals negative 2y minus 2. Apply division property of equality. Divide both sides by y minus 1. Y minus 1, y minus 1. Cancel out the common factor. And x equals negative 2y minus 2 over y minus 1. Let's find the range by equating our denominator to 0. So y minus 1 equals 0. Apply addition property of equality. Y minus 1 plus 1 equals 0 plus 1. Negative 1 plus 1 is 0. Then y equals 1. And the range is all the values of y such that y is an element of real numbers wherein y is not equal to positive 1. Because 1 is the value of y that will make this expression undefined. Domain and range is related to the vertical and horizontal asymptote, which will be discussed by Sir Eli. If we will graph this rational function, let's sketch this graph. The value of x that will make the function undefined is negative 2. Negative 2. So, negative 2 will be the vertical asymptote of this rational function. While the range y is not equal to 1 will be our horizontal asymptote. So y is equal to 1. So that will be the horizontal asymptote. So this will be the graph of this rational function. Take a look at the behavior of our graph. The value of x in this part of the graph is approaching negative 2. Take note of the symbol, approaching, because this graph will not intersect our vertical asymptote. And in this part of this graph, the value of y is approaching positive 1. The graph will move closely to y equals 1, but it will not intersect on the horizontal asymptote. In this part of the graph, y is approaching positive 1. And in this part of the graph, x is approaching negative 2. Let's find the dominant range of the rational function f of x equals 2x plus 1 all over x minus 3. Again, the first step is equate our denominator to 0. X minus 3 equals 0. We write x minus 3 equals 0. Apply addition property of equality. Plus 3 plus 3. Negative 3 plus 3 is 0. X equals 3. Then, our domain is all the values of x such that x is an element of real numbers wherein x is not equal to positive 3. Because positive 3 is the value of x that will make our function undefined. 3 minus 3 is equals to 0. Next, let's find the range of this rational function. Again, f of x equals y. Then let's substitute y to f of x. Y equals 2x plus 1 all over x minus 3. Let's rewrite 2x plus 1 over x minus 3. Multiply both sides by x minus 3 to eliminate the denominator. X minus 3 and x minus 3. Apply distributive law. X times y is xy. Then, negative 3 times y is negative 3y. Cancel out the common factor. And bring down 2x plus 1. Let's solve x in terms of y. So we will combine the terms that has a variable x. Let's rewrite xy minus 3y equals 2x plus 1. Let's apply subtraction property of equality. Let's subtract negative 2x on both sides of the equation. Minus 2x. xy minus 3y minus 2x equals 2x minus 2x is 0. Bring down 1. Let's eliminate negative 3y by adding positive 3y on both sides of the equation. Plus 3y, 3y, plus 1. Negative 3y plus 3y is 0. So xy minus 2x equals 3y plus 1. Let's factor out. The common is x. Y minus 2 equals 3y plus 1. Divide both sides by y minus 2. Y minus 2, y minus 2. Then cancel out y minus 2. X equals 3y plus 1 all over y minus 2. Let's find the range of our rational function by equating our denominator to 0. Y minus 2 equals 0. Let's apply addition property of equality by adding positive 2 on both sides of the equation. Negative 2 plus 2 is 0. 0 plus 2 is 2. Then, our range is all the values of y such that y is an element of real numbers wherein y is not equal to positive 2 because 2 will make our expression undefined. 2 minus 2 is 0. That's all for this session. I hope you learn how to find the dominant range of a rational function using the different forms. I am Teacher Andrew and see you again here in Telemath Aralan. Bye!